Hello everyone, my name is Tanya and I am from ABES Engineering College. In today's lecture, we will learn about principal component analysis. We call it as PCA also. So today's table of content is the principal component analysis algorithm and practice problem of PCA. So basically, what is principal component analysis? So we all know about that. In today's world we have big data, and because of this we face the problem of dimensionality, because the big data is very vast and we have to deal with n dimensions. But it is not possible to calculate or to perform operation easily on n dimension data. So we need to reduce dimensions. So in reduction, we use some techniques to convert our n dimension data into 2 dimension. Okay. So the PCA basically is a dimensionality reduction algorithm, which is used to calculate some principal components which are along to the given data points. So there can be 2 principal component, or we can say that we can map calculated principal component in 2 direction only, x and y. X-axis and y-axis, we call it as 2-dimensional data. So the first component of this, after this algorithm, we calculate is tell us the variation of our data variables which are available. And the second one is used to hold the variation of these data variables. So the algorithm goes as to calculate these principal components. First, we need to calculate the mean vector. How can we calculate the mean vector? By taking the mean value of all x data points and y data points. In each data point, we have 2 components, x1, y1. And in second data point, we have x2, y2. So for calculation of mean value, we just use to add x1 plus x2 divide by 2, y1 plus y2 divide by 2. So this is the process of calculating mean, and we can calculate mean of n number of data points. After that, we need to subtract the mean value from the given data. And after that, we have to calculate the covariance matrix. How can we calculate the covariance matrix? For the calculation of covariance matrix, the result we got from the step 2, that is, we had subtracted the mean from the given data point. And then for covariance matrix, we sum up all the differences from the step 2 with their transpose. Then after calculating the covariance matrix, we are going to calculate eigenvector and eigenvalues. And then we will choose our principal component on the basis of the value of eigenvector and eigenvalue. Then after the calculation of this eigenvector, we will map our data point according to the calculated eigenvalue. Now learn it with the help of a given problem. So we can have the same problem in various 3 statements or 4 statements. So first is the given data. We have given a data set, that is 2, 3, 4, 5, 6, 7, then semicolon. Why they have used semicolon here? Because they are trying to represent these are the value of x-axis and these are the value of y-axis. With the help of semicolon, they have separated both axis data. So 2, 3, 4, 5, 6, 7, these are the x-axis value of giving data point, and 1, 5, 3, 6, 7, 8, these are the y-axis value of data points. Now we have to calculate the principal components by using PCA algorithm. Again, this question can be written as, consider the 2-dimensional pattern for the given data points. Here we have the data points in form of x, y. The next one is, we have 2 classes. First class for giving data point, And in this, we have x value for x and value for y also. And then in class 2, we have value of x and we have value of y also. So we can write our data point as x1 is equals to 2, 1, x2, or we can write it as a1, a2, because of x1, x2 we will use in further calculation. So a2 is equals to 3, 5, a3 is equals to 4, 3, a4 is equals to 5, 6, a5 is equals to 6, 7, and a6 is equals to 7, 8. So here we have 6 data point, and now we have to calculate the mean vector of the given data point. So we are representing the mean with the help of symbol mu. So mu is equals to, we have to calculate mean value for x-axis values also and y-axis value also. So for that, we just sum up all the value of x-axis 2 plus 3 plus 4 plus 5 plus 6 plus 7 and divided by, we have 6 data points here. So divided by n, and n is equal to 6 here, comma. The y-axis value are 1 plus 5 plus 3 plus 6 plus 7 plus 8 divided by 6. Okay. So after calculating these values, we got mu is equals to 4.5, 5. Okay. And we can write our mean vector as 4.5 for x-axis value and 5 for y-axis value. We here I have written this mean vector in form of matrix because in further process we will work on matrix. So next is, after calculating the mean vector, we need to subtract this mean vector from the given data point. Then we calculate it as x1 minus mu is equals to 2, 1 minus 4.5 and 5. For x2 minus mu, 3, 5 and 4.5 and 5. So for all 6 data points, we just subtract the mean value from the given data point. So we got the values after the subtraction. I am writing here after the subtraction. Okay. Minus 2.5 minus 4. Then, and how can we calculate these values? You can see here, x1 minus mu, here we have 2 and 1 as x1, x2, x1, y1 value of data variable a1, and then 4.5 and 5 in mean value. So 2 minus 4.5 is equals to minus 2.5 and 1 minus 5 is equals to minus 4. Okay. I am writing it here as x1 minus mu, a1 minus mu. We are referring our data point as a1, a2 here. Okay. a1 minus mu is equals to 2 minus 1, comma, 2 minus 4.5, comma, 1 minus 5. That is equals to minus 2.5, comma, 4. For a2 minus mu also, 3 minus 4.5, comma, 5 minus 5. So value we got here minus 1.5, comma, 0. So we can calculate for all 6 data points these subtracted values. So for A3, 4 minus 4.5, comma, 3 minus 5 is equals to minus 0.5, comma, 3 minus 5 is equals to 2. For A4, 5 minus 4.5, comma 6 minus 5 is equals to 0.5, comma 1. Okay. So in the next slide, I am writing all the calculated values for these data points. Minus 2.5, minus 4 for A1. For A2, it is minus 1.5 and 0. For A3, it is 0.5 and 2, minus 2. And for A4, it is 0.5 and 1. For A5, it is 1.5 and 2. And for A6, it is 2.5 and 3. Now we will create the covariance matrix. So for the creation of covariance matrix, we use the formula I'm writing here. Covariance matrix is equals to 1 upon n. N is here the value of total data elements. Okay. 1 upon summation of all all ai minus mu multiply with ai minus mu with its transpose. Okay. So for covariance matrix, we just multiply the subtracted value, the subtracted matrix with its transpose. For data point A1, I am calculating it here. M1 is equals to minus 2.5 minus 4 multiply with the transpose of this matrix minus 2.5 and 4, which is equals to 6.25, 10, 10 and 16. How I have got this values? Just we have multiplied all, we have applied the matrix calculation formula here. Matrix calculation, matrix addition, matrix multiplication, we have already learned in our previous subject also, in our mathematics also. So minus 2.5 multiply with minus 2.5 is 6.25. Minus 2.5 multiply with 4 is 10. Minus 4 multiply with 2.5 is 10. And minus 4 multiply with 4 is equals to 16. How? This is how we got these values. For M2, minus 1.5 and 0 multiply with minus 1.5 and 0 is equals to 2.25. Here we multiply minus 1.5 with minus 1.5 is equals to 2.25. 0 with 1.25, that is 0. Minus 1.25 is 0, and 0 with 0 is 0. So this is the matrix we got here. And for M3, 0.5 minus 2 into 0.5 and minus 2 is equals to, now we are multiplying 0.5 by 0.5 is equals to 0.25. And then minus 2 with 0.5, that is 1. 0.5 with minus 2, that is 1. And minus 2 with 2 is 4. So for M1, M2, M3, we have values here. And for M4, we got values 0.25, 0.5, 0.5 and 1. For M5, we got 2.25 and 3 and 3 and 4. For M6, we got 6.25 and then 7.5, then 7.5 and here 9. So now we have all M1, M2 up to M6 values of these matrices. Now we sum up all these matrices to calculate the covariance matrix, and then we will divide it by n. So our final covariance matrix is equals to 1 by 6 into multiply with addition of all these values m1, m2, m3, m4, m5, m6. So we, in addition of matrix, we just add a1 plus a2 plus a3 plus a4, a1 of all matrix, then a2 of all matrix, then b1 of all matrix, and b2 of all matrix. So 6.25 plus 2.25 plus 2.25 plus 0.25 plus 2.25 and 6.25. Like this, we will add all these values and we got 17.5, 22, 22 and 34. So the final value is 2.92, 3.67, 3.67 and 5.67. Okay. Now we will calculate the eigenvalues and eigenvectors with the help of this covariance matrix. So the formula for the given eigenvalue and for calculating the eigenvalue and eigenmatrix is, we just need to subtract 2.92. We just need to subtract the lambda matrix from it. So lambda 0 and lambda 0. This. So this is the diagonal matrix, because we are finding the principal component, and for 2 dimensions we need to calculate a principal component which is diagonal in the direction, because we will map our data points according to that principal component. So 2.9.2 minus lambda and 3.67 and 3.67 and 5.67 minus lambda. Okay, from is equals to 0. So basically, for the calculation of the eigenvector and eigenvalue, we have the formula like this. The covariance matrix M1 minus the lambda matrix is equals to 0. So covariance matrix, we have write it here, minus the lambda matrix is equals to 0. From this, we got the equation. We got the equation like 2.92 minus lambda multiply with 5.67 minus lambda minus 3.67 into 3.67 is equals to 0. From here, 16.56 minus 2.92 lambda minus 5.67 lambda plus lambda square minus 13.47 is equals to 0. So from here, from this quadratic equation, after solving, we have the values of lambda is equals to 8.22, 0.38. So this is lambda 1 and this is value of lambda 2. So as compared to lambda 1 and lambda 2, the value of lambda 2 is very lesser than lambda 1. So we can left it out. So we here we are choosing a principal component, our eigen value, which will work as a principal component, that is 8.22. Now with the help of this eigenvalue, so here we have our eigenvalue lambda is equals to 8.22. We are discarding the lambda value of lambda 2 because this is very less as compared to lambda 1. So now with the help of this eigenvalue, we are going to calculate our eigenvector. So eigenvector we can calculate with the help of covariance matrix. M into X is equals to lambda X. X is with the help of X, we are referring the eigenvector. So here we have the value of M and the value of lambda. So with the help of these two values, we can calculate our eigenvector, which we are representing with the help of X. So the value of M is equals to 2.92, 3.67, 3.67 and 5.67. Okay? And now we are multiplying it with x1 and x2 is equals to, we have lambda value as 8.22 because we have only one eigenvalue, x1 and x2. So now we will simplify this equation. 2.92 into x1 plus 3.67 into x2 is equals to 8.22 x1. This is our first equation, and then second equation is 3.67 x1 plus 5.67 into x2 is equals to 8.22 into x2. This is our equation 2. How I have calculated this? Just I have applied the multiplication operation of matrix 2.92 with x1, then 3.61 with x2. The first row with first column, then the second row with the first column. Again, here the value with the first column. Now, with the help of comparison, we have formulated these two equations. And with the help of these two equations, we got the value of x1 is equals to 0.69 of x2. Okay. So, we can say that our eigenvalue is 8.22, and with the help of eigenvalue, we have calculated our eigenvector, that is x1 is equals to 0.69 x2. That means the value of x1 is depending on x2 is multiplied with the 0.69. Okay. Now here I have mapped the eigenvector, and now here you can see that the mapping of our given data point also. Our first given data point is 2, 1. A1 is 2, 1. So on x-axis is 2 and on y-axis is 1. 1, we have the value A1 2, 1, and here is the mapping of this this giving data point with the eigenvector. Okay. The next data point A2 was our next data, our 3, 5. So on x-axis 3 and on y-axis 5. So this is 3, 5. This is our A2, 3, 5. Then A3 is 4, 3. So 4 on x-axis and 4 on x-axis and 3 on y-axis. This is our data point A3, 4, 3. Then A4, the value of A4 is 5, 6. So 5 on x-axis and 6 on y-axis. This is our A4. 5, 6. Then our A5 is 6,7. 6 on x-axis. 6 on x-axis and 7 on y-axis. So this is our data point A5, 6, 7, and the last one data point A6 is 7, 8. 7 on x-axis and 8 on y-axis. So here we have mapped all our data point with the relation with our eigenvector. Okay. So thank you for the today's video.